Hello everyone. Today let us talk about the one of the very important solar energy gadget, that is solar photovoltaic system. In short, it is called as solar PV system. What is solar photovoltaic system? It converts the solar energy into direct current electricity using solar cells, which are normally made up of semiconducting material. That is the PV system. It is made up of solar cell. The its smallest unit is the solar cell, and these solar cells, they are made up of semiconducting material. Now the photons of the light that hit the solar panels, they knock the electrons that are present in the material, this semiconductor material, into high energy activity. Now these electrons, they are channeled through the panel and they create the DC current. So what does it mean? That the semiconducting material that is present in the solar cells, they release the electron when they trap the photons or the light energy from the sunlight. Because of the photons, that is light energy received from the sun, it initiate the electrons to come out of the semiconducting material. Now these electrons, they are panel to produce the electricity. So in most of the cases, an inverter is used to current this DC current into AC current, so that it is making more directly usable to the consumer, because all the modern electric appliances, they work on the AC power. Next, this is the schematic presentation of solar photovoltaic system. Here you can see that this is the solar radiation which, when fall on the solar array, then the semiconducting material that is present inside the solar cells, they start liberating its electron, and these electrons, they are channeled through the charge controller, and it is used to produce the electricity, which is then stored in the battery tank. Then this battery is connected to the inverter. This is actually the direct current that was produced by this system. This DC current can be used by some of the appliances, some of the materials that are present in the home, whereas the most of the modern appliances, they are using the AC current. So the inverter will convert this DC current into AC current, and through this board, distribution board that is present domestically in our houses, it will help to run our various appliances. Now let us talk about solar photovoltaic system in detail. The photons of the light hitting the solar panel, they knock the electron in a substrate material into a high energy level of activity. These electrons, they are channeled through the panel to create the DC electricity. So the inverter is connected, which will convert this DC power into AC power. Now what is that semiconducting material that is present in the solar cell? The semiconducting materials are silicon, cadmium sulfide and gallium arsenide. These are used to fabricate the solar cells. So this silicon is actually a semiconductor, that is a half conductor. It needs to be doped, means doping is done. It is silicon is added with some doping material. Now in the solar cells, the PN junction is created. A semiconducting material, when it is doped with the donor impurities, some of the impurities, that the doping material, that are phosphorus, arsenic, antimony, they are used in this. Along with it, these are used for doping the semiconducting material, that is silicon. Now this will increase the electrons in the conduction band, and it become a N-type terminal. So when the semiconductor is doped with an acceptor impurities, it becomes the P-type material with the excess holes. So between the P and N junction, there will be a limiting layer in between them. This is how the photovoltaic system P and N type junction, it looks like in the solar cells. So it will release the electron. So this electron will travel and enters into the P terminal. So there is an interface between the P and N, which produces an electric field, and it is called a cell junction. Now when the solar cell is exposed to the sunlight, a certain percentage of incoming photons, they are absorbed in the region of junction. Now thus electron is released from the silicon crystal. Then if the photons have high energy, that is enough The electron will be able to overcome the electric field at the junction, and they are free to move out through the silicon into the external circuit. So that produced electron with the high energy, they will move in the circuit. Now the direction of the electric current is opposite to the direction of the device. These are the three different types of solar cells: single crystalline, polycrystalline and amorphous type of solar cells that are available in the market, which you can see with the help of different color difference. You might have seen the solar arrays with the which are blue in color, and some solar arrays they are black in color. This is all because of the type of the solar cells they are using in the arrays. So the and you can see that single crystalline silicon. So this has a good used in the space and the ground facilities. Then here the lower space is required and efficiency is high. Amorphous type silicon solar cells, they have a low efficiency. This monocrystalline solar panels, they have a long lasting, and it lasts around 25 years. But the polycrystalline, their life is not that much as compared to the monocrystalline, and the amorphous type silicon solar cells, its life is very short as compared to the three. High temperature have more impact on the solar panel performance. So when the high temperature is there, then these solar panels are more effective. But in the polycrystalline, high temperature have the less impact on the solar performance than the monocrystalline. Then here also in amorphous type, the high temperature has the less impact as compared to the other. Now the shading have more impact on the solar panel performance. If there is a cloudy in temperature and weather, then it will have more effect on this single crystalline. But if there is a shade or the cloudy, it will not affect the solar panel. Here also the shading will have no effect, less effect on the amorphous silicon. It's when we see the efficiency percentage, the efficiency of single crystalline is very high as compared to the other two. Then what are the components, major components in the solar photovoltaic system? Photovoltaic system must have PV module, which you called as solar panel, so energy storage, battery, charge regulator, inverter and the load. So the components other than PV module are collectively known as the balance of system, BOS, which includes storage battery, charge regulator and an inverter. So these are called as balance of system. They balance the system, solar photovoltaic system. Now when we consider one solar module, thus it contains a solar cell. Solar cell is the basic unit of the photovoltaic system, and one solar cell can produce the power between 1 to 2 watt. So in case of when we consider a single crystalline silicon solar cell, it covers an area of 10 into 10 centimeter, and the output power that is given is 1.5 volts power. For the actual usage, the solar cells are interconnected. One solar cell cannot produce enough electricity. So as you can see that one solar cell can produce only between 1 to 2 power. But when the solar cells they are connected in the array, when they are connected parallelly in the series, then they are actually producing the more current.